In, in this lesson, we are going to actually review one of the most important skills from algebra, namely, what is about the slope of the line. We are going to see how to quickly calculate the slope, and then we'll also use it to identify parallel and perpendicular lines. Each one of those pieces are things that you would have done in algebra. This is intended to be more of a quick review, saying, hey, remember that stuff that you did before and your teacher told you was really, really important? Don't forget it because we're still going to need it for future work. 3 pieces of slope that you ought to remember. How do you get slope? Slope is rise over run. And we know then, or rather it's been my experience that most students after working with slope will remember that slope equals rise over run. They remember how to get the number. That's not enough. That skill is of course valuable. You have to be able to calculate the number for slope, but you should also remember what it means. Because what it means, that has the role of interpreting it, especially in word problems, and we know how important word problems are to geometry. Slope is a measurement of how steep a line actually is. Do you have a line that rises slowly? Do you have a line that rises quickly? Do you have a line that falls down super, super fast? Is it flat? With every one of these types of lines, we can have a number measurement for how steep it is. And that's all slope is. In order to calculate it, you'll need 2 points. From those 2 points, you would be able to calculate the rise, how far up or down it goes. And in algebra, you went through 2 different ways of doing that. If you've got the picture, it's just counting. You can simply count 1, 2, 3, 4, 5, 6. There's our rise of 6. You can do the same thing for run. If you've got the picture, you can simply count 1, 2, 3, 4 to get the run of 4. Counting was, of course, really easy. That requires you to have the picture. You also would have gone over the formula to get slope. That rise over run, we could get by taking and finding the difference between the 2 y-coordinates. In particular, if this has a y-coordinate of 7, and this is a y-coordinate of 1, 7 subtract 1 will give us that rise of 6 that we got by counting. And of course, we have to do the exact same thing for the x-coordinates. Our x-coordinate here is 5. Our x-coordinate there is 1. So 5, get me back to the blue color. Finding the difference in x-coordinates, 5 subtract 1 gave us 4. Depending on if you have the graph or not, you can count out rise over run. There's no problem with doing that. You can also use the slope formula. It is a matter of preference. However, you should still know the formula. You should be able to use the formula because when you get farther into classes, it will be necessary. You will have to do it for some problems. Now, find the slope. What is the slope of this line AB? Well, very rapidly, we can do 3 different things. A and B are located here, so of course we're looking at this line. And Chance, you told me something right away. What's the slope?
Nil.
Nothing. It's a 0. It's a good thing to remember that every horizontal line is going to have a slope of 0. Why? Well, if slope is rise over run, how much does this line rise up or down? It doesn't. With a rise of 0 and a run of whatever number you want, that's going to divide out into the number 0. So we could just count rise over run, that's fine. I do want to point something out though. Pay attention to what the directions told us to do. Use the slope formula. What do they mean by that? Do they mean the formula rise over run where you can count? Or do they mean the y2 minus y1 where you actually put the numbers in? Yeah. Okay, you guys are telling me they mean the second one, so I'll admit I don't think those directions are super clear. There's more than one formula for slope. I think rise over run is a slope formula. But for the purposes of practicing, I do want to make sure that we can look at the coordinates of the points and identify that point B is located at 3, 7. A is located at -2, 7. And so when we actually put in the slope formula that you said, we have 7 minus 7, 3 subtract -2. And you see why we did the warm-up problems that we did? The slope. 7 minus 7 is 0, 3 subtract -2 is 5, and we get our answer of 0 as well. With your marker boards, I'd like you to do the same thing. What is the slope of this line AC? And I'll pause to give you time to work. Given that we have this graph, what we're supposed to be looking at is thinking of this rectangle, or this triangle, where we can figure out our rise and run. Now, because this is graphed, let's just do the quick count, rise over run. 1, 2, 3, 4, 5. Now I do want to emphasize that this is going down 5 from the left to the right. It's saying down 5. And now counting to the right, 1, 2, 3, 4, 5, 6. So we went right 6. Thus, our slope, rise over run. -5 over +6. That, of course, would just be -5/6 as a slope. And we're done. Please do this one. So one component that you, of course, need to be careful about, this line AB is not a horizontal line, it's perfectly vertical. And there's a tendency sometimes for students to make the mistake that if you have a completely horizontal line, the slope is 0. That's correct. Sometimes students will say a vertical line also has slope of 0, and that's not accurate. When we're looking at this one, yes, I know that we could simply count out rise over run, but I wanted to emphasize 2 to the left, up 1, 2 to the left, and up 7. If we go through and actually apply the formula, we would be able to get our rise. 7 subtract 1 gives us a rise of 6. Of course, we could count that as well. A different technique to get that number. And then the run, -2 subtract -2, that's 0. And 6 over 0 is a very different thing than 0 over 6. We cannot divide by 0, so this tells us that the slope is undefined. A lot of times teachers prefer to use the simpler way of saying that, but there is no slope. Yeah, it's a no solution type problem. In particular, every single perfectly vertical line will not have a slope. And just to reiterate, if you prefer to have something written down for your notes, If you wind up with a fraction with 0 in the denominator, that is undefined because we can't divide by 0. It's impossible. Last one. What is the slope of the line CD? Pause the video, try it out. And because I think it's the easier method, it's going to count. That's up 1. There's my rise. And then I'm going to the right. 1, 2, 3, 4, 5, 6. So right 6. There's my slope, 1 over 6. Here we have a little bit more challenge. If we're not actually given the graph, we have two things that we could choose to do. Do you want to actually go through and graph the points so that we could look at a picture and see rise over run? That way we could count it. It's a valid strategy. You can do it that way. Personally not a fan because I think the amount of time that you spend drawing the graph and then actually putting the points down and connecting them, I think it takes longer to draw the picture than it does just to do the algebra with the formula. That's my preference. I'm not the only one in the world though. There are people who would rather do the graph. And if you're one of them, go ahead, that's fine. It's just for this one, I'd rather go through and quickly use the formula and just do two pieces of subtraction. I'm going to take -1 and 1, subtract them. Take 2 and 3 and subtract them. -1 subtract 1, of course, equals -2. 2 subtract 3 equals -1. And -2 divided by -1 gives me +2. I'm done. For my brain, it's faster to do that than to create the picture. That's why I like it. And just as a quick review, pieces that you should remember. If it rises, you've got a positive slope. If it's falling down to the right, it's negative. Flat is 0 slope. Straight up and down is an undefined slope. Now, of course, given that we are a geometry class and geometry is all about applicability, we want to be able to see how does this stuff actually get used. So Justin's driving from home to his college dorm. At 4 p.m., he's 260 miles away. 7 p.m., he's 455 miles away. Graph a line that represents his distance from home at a given time. Well, I would like to point out, I do not expect you to have a perfect graph. If you're going to use a sketch and draw it by hand, I don't have a problem with that because we could simply look at it and say 4 p.m., 5 p.m., 6 p.m., 7 p.m., 1, 2, 3, 4, 5, so 100 miles, 200 miles, 300, 400, 500. I don't expect you to go through and draw one out with absolute perfection. If you want a more accurate, precise graph, we of course have graphing paper for you to use. Just plot them now. 4 p.m., it's 260 miles. 7 p.m., it's 455 miles. And once we've plotted our 2 points, let's connect them. There. We've created the graph. So graph the line. Done. Now what's the slope? Well, of course, this is a problem where it doesn't really make sense to try to count rise over run. It was a quick sketch, it's not a perfect one. Instead, let's get our slope. The rise would be 455, subtract 260. Well, what's that number? Okay, that's 195 miles. And 7 minus 4, There's 3. And 195 divided by 3, that equals 65. That is finding the slope, and in general, it's been my experience that when students come back out of Algebra 1, they don't have a problem doing these two things. The part that they usually forget how to do, or perhaps they forget to do it at all, is the second part, interpret it. I've seen a lot more students not remember how to interpret the slope. Interpreting the slope is all about remembering the labels on what you were doing. What was this 195? It wasn't just the number 195, it was 195 miles that Justin drove. The number 3 wasn't just the number 3, it was a 3-hour-long period in which he was driving. This is telling us then that if you drive 195 miles in a period of 3 hours, on average, your average speed, the labels are still going to be applied here. To interpret it, we would have to use those labels and say Justin drove an average of 65 miles per hour. It is important for you to remember, slope is an average rate of change. Slope is an average speed of something. Whenever you interpret it, you'll want to remember that. You will use labels when you interpret them. Another skill that sometimes students forget, we could use them to estimate solutions. So here we have a graph. How far will Tony have traveled by 6:30? Okay, if his average speed stays the same, this section right here is just saying, okay, the line is going to continue. It still stays a line. It doesn't start changing its shape or anything like that. Okay, so if we're saying by 6:30, all we need to do is come up to 6:30 in terms of a time period. 6:30 is, of course, 6.5, 6.5 hours. So we come up and come over toward here and say, where is that? Well, coming right back over, and I can't see that because it's right along. Well, that's 400. If we try to maintain the same type of a gap, that would be 500. As an estimate, about where is that? About 450 miles. And please note, this is only an estimate. If we wanted to have an exact answer, algebra showed us that we could create an equation, and then we could plug in 6.5 hours, and we could solve an equation. Okay, so finally, how does this stuff tie into geometry a little bit? This is, again, a fact that you would have discussed in algebra. You do use it, but most of the time, it doesn't seem like it's a really important thing in Algebra 1, so a lot of times students don't remember it. These two things are very, very straightforward. Parallel lines will have the same slope. So if you have two lines and one of them is a slope of 3, one of them is a slope of, the other one is a slope of 3, that tells us that they're going to be parallel lines. As long as they're two different lines, we've got parallel. Perpendicular, it says that the products of their slope are -1. Oh, this one would say perpendicular lines have opposite reciprocal slopes. These are a couple facts that you used in algebra. We want to emphasize them again because they play a more significant role for us. In particular, when you're working with perpendicular lines, if one of them has a slope of 3/5, flip it to get the reciprocal, change the sign, negative and positive pair. Lines with slopes like this will be perpendicular to each other. And so we are, of course, curious, are the lines parallel or are they perpendicular? But you do want to be careful because it is possible that all 4 points that we give you could be on one line. They could be collinear. And when that happens, it's frequent for students to make the mistake by not checking that they're actually two different lines, which is why it's helpful to have a graph. So we've got these two pairs of lines. Plot them on your marker boards, connect the dots. I'll pause the video while you do that. All right, when we look at these things, we'll get a graph that looks like this. Of course, we had the point 0, 2, left and right 0, up 2. We had the point -1, -1, left 1, down 1, and we connected those 2 points to create UV. We also came through 3, 1, 3 to the right, up 1, -3, 3, left 3, up 3, to give us these, and now that we have them graphed, are these parallel, perpendicular, or neither? Visually, it looks kind of close to a 90. Is it a perfect 90? No, we're not sure. Doesn't really look like it, but this is why we have our formula. This is why we have our theorem, because we don't have to say, well, it kind of looks maybe. We can actually calculate the slopes and be absolutely certain, are they perpendicular, yes or no? And so, over here with the blue, we're going to note a rise of 3, a run of 1. 3/1 gives us a slope of 3. With the red line, we have down 2, 1, 2, 3, 4, 5, 6. So down 2, right 6. That simplifies to -1/3. And I'd like to ask you then, are those negative reciprocals or opposite reciprocals? Yes, they are. And so, based on this algebraic evidence, we know that those lines actually are perpendicular. And it could simply be a matter of, did you create a really pretty accurate picture? Well, we could do the same thing here as well. And just in the effort of the instance of saving a little bit of time, I've already got the graphs put up. That way you can verify. Graph the points, connect the dots, and then let's get our slopes. Alright, looking at our work, what we noted, of course, we've got the lines graphed, and between our points G and H, we could calculate a run 1, 2, 3, 4, a rise of 1, 2, 3, 4. So our slope, rise over run, is just 1. And for the other line, well, it doesn't look perpendicular. It kind of looks acute. But again, we've seen before that looks can be deceiving. We have to trust our theorems to tell us accurate information. So here we'll take our 2 points and figure out the rise and run. Here we have 1, 2, 3, 4 for the run. 1, 2, 3, 4, 5, 6, 7, 8 for the rise. But since it was down 8, we'd have rise of down 8, a run of right 4. That would be negative 2. Are those opposite reciprocals? No. Are those equal? Clearly no. And so that tells us that these 2 lines are neither parallel nor perpendicular. They're simply intersecting lines. And now take a moment, graph those 4 points. And after checking people's work, what we're seeing, the point C, negative 1, 3, would have been left 1, down 3. 1, 1, 2, 3. The point D, 1, 1, that tells us right 1, up 1, so right 1, up 1 gets us to point D. And what I was seeing, of course, is when people were plotting their points, they didn't immediately connect these lines. I recommend that you do. Now that we've got our 2 points, we connect them to actually draw. And please notice, I didn't stop at the points. I kept the pattern going all the way through. So, negative 1, 1. That's left 1, up 1. Left 1, up 1. And our second point, 0, 3. Left and right, 0. Just up 3. So, up 3. And once we've got them graphed, visually, it's really easy to see those are parallel lines. Okay, so McKenna asked the question, did I flip the triangle? When I did the first one, I went left and down. Here I went right and up, so it was like this. It doesn't matter if you're doing it like this mental triangle above or below, because if I did it right 1, up 1, I wind up there. If instead I think up 1, right 1, I get to the same location. I'm just on the other side. It really doesn't matter if you're going right and left first, up and down second, or if you do it backwards, up and down first, left and right second. As a general rule, for the way my brain works, I think of X and Y. I tend to prefer left and right first, up and down second. It's easier for me to think that way. But it's perfectly fine to do it the other way as well. Now, I wanted to emphasize again, calculating slope, interpreting slope, those are things that you absolutely were expected to come out of Algebra 1 already knowing. The geometry component where we build, and therefore the geometry component that I expect you to know, is here. Will focus in our class more on determining if lines are parallel, perpendicular, or neither. We will focus in the future with equations of lines, not as much on what is this slope. What is this slope is an algebra thing. I expect you to already have that skill mastered.